Hello and welcome to Forrester High School Maths Department's Level 3 Support Materials. My name is Mr. McDonald and I'll be talking you through your topic today. In today's lesson we are going to be identifying scale factor and we're going to be looking a step further and identifying area factors and volume factors from those scale factors. So, whereas scale factor describes the magnitude of change or the multiplier that changes the side lengths of two shapes that are in scale, the area factor describes the magnitude of change in the area, and the volume factor describes the magnitude of change in the volume. So these three things, scale factor, area factor, and volume factor, are all linked, but they are not the same number. Here's a small example of two shapes that are in scale here and that we can find the area of quite easily. Okay, so I've got a 2 by 2 square on the left hand side and a 6 by 6 square on the right hand side. So I know that the scale factor is just going to be SFE, scale factor enlargement, is going to be 6 divided by 2, which is 3. But let's take a look at these areas. Now, if I count up the area from the first box, I have 4, let's call these centimeters squared. And if I count up the area of the bigger box, that's 6, 12, 18, 24, 30, and 36. Okay, so I've got 36 centimeters squared on the larger box. Now you can see that the scale factor is times by 3, but the area factor is actually times by 9. So if I say the area factor is 9. And you can do this for any set of rectangles or any set of shapes that you can find the area for. And the general rule, if you investigate lots and lots of these shapes, is as follows. The area factor is equal to the scale factor squared. Now remember that a square number is just a number that is multiplied by itself. So to get from the scale factor, which is 3 at the top of the page here, to the area factor, which is 9 at the bottom of the page here, I just do that scale factor times by itself, which gives me the 9. So let's take an example from the very beginning, like you'll see in your assignment on Show My Homework. I've got two shapes here in scale, and I need to find the area of the second shape by eventually finding the area factor and then using it like I would use a scale factor. Okay, so step number 1. What I'm going to do is I'm going to find the scale factor. That's nice and easy. SFE, scale factor enlargement, is just the side of the bigger shape, which is 30, divided by the side of the smaller shape, which is 3. And we know that 30 divided by 3 is 10. Okay, so that's my scale factor enlargement. Step number 2, I'm going to find the area factor based on my scale factor. Now, as we learned in the previous slide, area factor is just scale factor squared. So I'm going to take my scale factor, which is 10, and times it by itself, which is the other way of saying 10 squared. So my area factor is 100. So this tells me that the area of the smaller shape, if I multiply that by 100, I'll get the area of the larger shape. So our last little bit here is to write down area. This is the area of the bigger shape that I'm trying to find. Area is going to be equal to 15, which is the area of the smaller shape, multiplied by our area factor, which is 100. So our final answer is that this bigger shape has an area of 1,500 centimeters squared. It's a nice little reminder of what you have to do to the area factor is the fact that areas are always measured in centimeters squared. And to find the area factor, you square the scale factor. So if you want to, you can pause the video here and have a go at question 1 of your assignment on Show My Homework. That's all about finding and using area factors, just like the previous example I did there. If you want to continue to watch the video and then do your assignment at the end, then by all means keep watching. But if you want to stop here and complete question 1, pause the video now before I move on. Okay, so the second type of example we're looking at today is volume factor examples. That's when we're dealing with 3D shapes instead of 2D shapes. It's very similar to area factor, apart from we're not going to square our scale factor to get our volume factor. We're going to do something slightly different. Okay, on the left hand side here I've got a 2 by 2 by 2 cube, and on the right hand side I've got a 4 by 4 by 4 cube. So finding the scale factor should be quite easy. Our scale factor enlargement is just one side length divided by the other. The bigger side length is 4. Our smaller side length is 2. So 4 divided by 2 is 2 as our scale factor of enlargement. If I want to look at the volumes of this, I can count up every cube that is on this shape here, and there are 8 centimeters cubed. So I might just put V equals for volume equals 8 centimeters cubed on that first one. And the second one, I'm not going to count every single individual square on this or cube on this, but if you take my word for it, the volume of this shape is 64 centimeters cubed. So our scale factor of enlargement is 2. Our volume factor, what if I had to times 8 by to make 64? Well, our volume factor is 8. So I have not squared that 2, our scale factor, to get 8, our volume factor. The rule is, when you're doing volume factors, volume factor is equal to the scale factor cubed. Now you may not have run into the term cubed before. What cubed means is a number times itself and then times itself again. So in this case, our volume factor of 8 is being found by doing 2 times 2 times 2. Okay, because the first 2 times 2 gives you 4, and then times that answer by another 2, and that gives you 8. Okay, so volume factor is equal to the scale factor cubed. Another way you could think about that is the scale factor times the scale factor times the scale factor again. So let's look at an example here. I've got 2 unusual looking 3D shapes. They're both in scale. I know the volume of the first one, but I don't know the volume of the second one. And we're going to use our volume factor to figure out that volume. So step number 1, just like in the previous example with area factor, we're going to figure out the scale factor first. So SFE, scale factor enlargement, is equal to the bigger side that matches divided by the smaller side that matches. Now you've got 2 choices here. You can do 2.7 divided by 0.9 because those are matching sides, or just as easily you could have done 2.5 divided into 7.5, and that would give you the same answer here. Our scale factor enlargement is 3. Okay, next little bit. what we're going to do is we're going to find our volume factor. So VF for volume factor, that's going to be our scale factor, which is 3 times 3 again, times 3 again. If you want to write down the notation 3 cubed there, 3 with a little 3 at the top, then you can as well, instead of 3 times 3 times 3, which can be a bit tedious to write out. Our volume factor is 27. Okay, so last little step. I need to do, for my volume, the volume of the small shape that I know. So it's going to be 30 times by my volume factor. So 30 times 27. If you're good at your mental maths, you know that 3 times 27 is 81. So 30 times 27 is 810. And that's going to be centimeters. But in this example, instead of a wee squared sign, I'm putting cubed because we're dealing with a 3D shape there. Okay, and that is how to use a volume factor. You can go ahead now and complete question 2 of your assignment. You can remember, watch this video again and again, pause if you need to take notes. One thing I will ask you to do is try and make your working as similar to my working as possible. So you should have a scale factor, then a volume factor, and then an answer. Or if you're doing the first examples, a scale factor, an area factor, and then an answer. You can ask for advice on Show My Homework at any time. Remember, I'll message you back either through Show My Homework or through email. And the deadline for this activity is Friday the 15th of May. Well done for getting through this video, and best of luck on your assignment.